Okay, let's go and do the next question. Consider the following system of linear equations. W positive 3, x positive 2y positive 2z equal to 0. W positive 4x positive y is equal to 0. W 3w positive 5x positive 10y positive 14z is equal to 0. 2w positive 5x positive 5y positive 6z is equal to 0. Okay, now this is the all important part here. They're giving us with the solutions of the form w comma x comma y comma z and w comma x comma y comma z are all real. Which of the following statements you can say is false? Sometimes they might say are false. That means more than one statement is false. So what is the understanding here? We're given a linear system. So that is the first point. Now let me go and give you the choices. The system is consistent. Number 2, the system has infinitely many solutions. Number 3, the sum of any two solution is a solution. Number 4, negative 5 comma 1 comma 0 is a solution. Number 5, every solution is a scalar multiple of negative 5 comma 1 comma 1 comma 0. Okay, so it's quite a sum, right? So this is a very powerful concept, and this concept is predominantly used in machine learning. So you will get to see problems like this more too often in the coming days. Okay, having mentioned that, let us try to understand what is given and what is expected from us. Foremost, we are given a linear system, or in other words, linear equation. We are given equation 1, equation 2, equation 3, equation 4. Now study the equation. What do you see? This is a solution. The equation is of the form a capital X is equal to 0. This is a form. This is point number 1 observation. Now, what is the meaning of this Ax is equal to 0? It means we have the variables on the left hand side, and on the right hand side we only have 0, 0, 0, 0. No other values. So what do you call such a system? This is a homogeneous system. This is the second point. Now the third point, we are seeing the term consistent. The system is consistent. This is a choice, right? Now we need to understand what is the meaning. What is the meaning of a system being consistent? Yes. Okay. What is the meaning of this term? Do you know? Okay, let me give you that information. So this is the concept or the knowledge point. A system is said to be consistent if it has at least one solution. And the all important word is at least. It is important, it is necessary for a system to be consistent that it should have at least one solution. So this is the yardstick that we measure. Now, coming back to the question. So what is the solution we started with? We found that the system is homogeneous. And is of the form, what is the form? Ax is equal to 0. So we know all homogeneous systems are consistent. Okay, so this means choice A is true, right? Now this is the additional concept information I'm giving. Now what is the meaning? What means that homogeneous systems are consistent? What is the meaning of this? This means that there exists at least one solution, okay, for the system. In case of Ax being equal to 0, clearly x equal to 0, 0, 0, 0 is a solution, right? So this is a very, very important point. Okay, so when instead of saying, so this is the variable x, so to be more specific, what I will do is I will rewrite this as clearly w comma x comma y comma z equal to 0, because we are dealing with Ax equal to 0, so I have just represented the vector there, but this will be a more specific representation. So let me rewrite that one more time. This means you have w comma x comma y comma z being equal to 0 comma 0 comma 0, 0 comma 0 comma 0 comma 0. Always satisfies every equation. That's the best word. Okay, so this is the explanation. You don't have to present all this when you're working, okay, because ultimately you will have to make the choice. But this gives you a clearer depth as to inform you why you are doing as to what you're doing. Okay, so let me move on. Now let us see if choice 2 is true or false. The system has infinite many solutions. Is this true or false? Now what do we see in the system? To answer this question, we need to know what do we see in the system. That's an all important question. So go up here. What do you see here? You see a w variable, a x variable, y and z. How many variables are there? There are 4 variables. So since the system as w comma x comma y comma z as variables, this means the system has infinitely many solutions. So that is the second one. So this means choice 2 is true. So we have just found this is true. Now we have found this is true. Now let's go and check if third one is true. So what does the third one say? The sum of any two solution is a solution. So this is point number 3. Let U and V be two solutions of Ax is equal to 0. So this means AU is equal to 0 and AV is equal to 0. This is 1 and this is 2. Adding 1 and 2, we get, so what do you get? AU plus AV is equal to 0 plus 0. This can be rewritten as A of U positive V is equal to 0. So what is the meaning of this? This means U positive V is indeed a solution, is it not? So let's go back. Sum of any two solution is a solution. So point 3 is also correct. Now we need to find if this is a solution. How are we going to do that? Okay, that's very important. Now to get to question number 4, we will have to go and check the variables or the system. So I'm going to choose 2. So from 2, we know that W positive 4x positive y is equal to 0. So this means we can have a representation of one variable in terms of the other variable. So this means W is equal to negative 4x negative y, which means W is equal to negative of 4x positive y in 1. So what is our 1? Our 1 is W positive 3x positive 2y positive 2z is equal to 0. So when we substitute this over here, this is going to be negative 4x negative y positive 3x positive 2y positive 2z is equal to 0. Negative 4x is added with, or I would say when we add these two, negative 4x and positive 3x, we get negative x. Negative 2y added with, or I would say negative y added with 2y is going to give me positive y. And then you have 2 times z is equal to 0. So from here, can I rewrite y to be as x negative 2z? Okay, fair enough. So I'm going to take this as 6. So what are the things we got now? We have w is equal to negative 4x negative y already, right? This is equation 5. So in place of y, you substitute this. So this is equal to negative 4x negative of x negative 2z. So this is going to give me negative 4x negative y positive 2 times z. So when we add, what do we get? You get negative 5x positive 2z. So this is our w. Now already we have y. Y is nothing but x negative 2z. So hence the solution is of the form, so w in place of w we would place negative 5x positive 2z. In place of x you just place x, and then y is of the form x negative 2z, and then you have z. So this is the form of the solution. Excuse me. Now what they are asking is in choice 4, negative 5 comma 1 comma 1 comma 0 is a solution. We need to know if this is true or false. We need to know that. Now clearly, what do we see here? Clearly we see that what? X is equal to 1 and z is equal to 0. We substitute these in solution. Okay, this is the form of the solution, in the solution form. So what do we get? Hence we get negative 5, x is equal to 1, 2 times z is 0, and x is 1, z is 0, and z is 0. So what is this? This is nothing but negative 5 added with 0, 1, negative 0, and 0. So what is this? This is negative 5, 1, 1, 0. And what is the form? This is exactly what is given here. So this means negative 5, 1, 1, 0 is indeed a solution. This means choice 4 is true. I'll just write 4 is true. But we are required to find the one that is false. Okay. Now to get the last one. Now what is the last choice they are saying? They are saying that every solution is a scalar multiple of negative 5, 1, 1, 0. Now do you know the meaning of this? This means the solution space of the given system is one-dimensional, right? Now we need to check the solution space. How do we find the solution space? The solution space is equal to number of variables in the system minus number of free variables. Now clearly if you were to see the number of variables in the system is 4, number of free variables is 2. So this means 4 minus 2, which is equal to 2. So this means the solution space is of 2 dimension. So this in turn means the choice given that every solution is a scalar multiple of negative 5, 1, 1, 0 is false.